This is number 11 from the pre-AP review worksheet for Unit 8. And this one is a hyperbola. We know it's a hyperbola because we have x squared minus y squared. So anytime you're subtracting, that's always going to be a hyperbola. When you subtract your x squared and your y squareds, or vice versa, y squareds minus x squared. So first thing we're going to do is put it into standard form. So we have 16x squared, but we don't have any x's. So we won't have to do completing the square for the x's. So we have negative 25y squared plus 50y plus a blank equals, we'll move negative 425 to the right. So add 425, it will become positive 425 plus 1 blank. All right, these can be a little bit tricky. We have to factor out the negative 25. So when you factor a negative out of a number, it's going to change the sign of both of these terms. It'll change both signs, so be really careful. So 16x squared minus 25 times the quantity, y squared minus 2y plus a blank. Now you can always distribute. Negative 25 times y squared is negative 25y squared. Negative 25 times negative 2y is positive 50y. So we've got to make sure that that's correct, or we're headed in the wrong direction. Equals 425 plus a blank. To fill the blank, we take half of our b term and then square it. Half of negative 2 is negative 1. Negative 1 squared is 1. So we add 1, and I always say, but did I really just add 1? No, I really added negative 25 because everything inside parentheses is being multiplied by negative 25. So now I've got 16x squared minus 25 times the quantity, y minus 1, it's always half of b, squared, equals 400. We'll divide everything by 400 because we know ellipses and hyperbolas in standard form are always equal to 1. So divide by 400. 16 goes into 16 once. 16 goes into 425 times. So we end up with x squared over 25. This becomes the minus sign between the two fractions. 25 goes into 25 once. 25 goes into 416 times. So we end up with y minus 1 squared over 16 is equal to 400 over 400 is 1. Ellipses and hyperbolas are always equal to 1. So when a hyperbola starts out with the x squared, it opens left, right. Your hyperbola will open to the left and to the right. If the hyperbola starts out with the y squared, if you have the y squareds minus the x squared, then the hyperbola would open up or down. I always think of it like looking like a Y, kind of like a Y on top if the Y squareds come first. And I think of it looking like an X if the X squared come first. So anyway, ours is going to open left, right. I've got my graph paper and now I'm ready to start. So my center is HK. H is always with X. So H is 0. K is always with Y. So K is 1. So I'm going to go to 0, 1 and put a dot. That is the center of my hyperbola. On the x-axis, 25 is associated with the x squared. That in a hyperbola, that is a squared. A squared will always come under the first fraction, and b squared will always come under the second fraction, just so you know. So 25 is underneath the x squared. We're going to move on the x-axis the square root of 25, which is 5. We're going to move 5 to the left, 5 to the right. and then just like an ellipse. On the y-axis, we're going to move up B, down B, so up 4 and down 4. Instead of making an ellipse, this time we make a little box. Like everything was going just like the ellipse until this part. So we make a rectangle. We draw the asymptotes. We draw the diagonals, which are called the asymptotes of the hyperbola. Remember, asymptotes are just lines that the graph follow alongside. They never cross the asymptotes. They just follow alongside. And now it's time to determine which way this graph opens. If x squared is first, which it is, it's gonna open like an X. I think of it opening like an X, left, right. So this point is our vertex. It looks like a parabola opening to the left and a parabola opening to the right. So these 2 points are called vertices. Those are the vertices. We are going to ask the coordinate of those vertices, and they would be -5, 1, and the other one is 5, 1. We're going to ask for the asymptotes. I always think of asymptotes, they're lines, and lines are always y equals mx plus b form. But notice that one of our lines has a positive slope and one of our lines has a negative slope. So instead of just slope, we're going to put plus minus m. Instead of just m, we're going to put plus minus in front. And just think of it without the b for just a minute, and then I'll explain what happens to the b. All right, we're going to take the equation and we're going to write the asymptotes. Whatever's with the y, you're going to place right here. So instead of y, we're going to have y minus 1 equals plus minus our slope. Slope is rise over run. We rose 4 and we ran 5. Rise is always associated with the y-axis. Run is always associated with the x-axis. So we rose 4 and we ran 5. And then in place of the x, whatever is with the x, like if you had an x plus 1, you would put an x plus 1. But x is all by itself, so it's just x this time. Okay, those are the asymptotes. Let's find the foci. The foci of a hyperbola will lie inside the hyperbola somewhere. I always use little x's to denote the foci. They'll be inside the hyperbola, so in the interior. So we're going to count from the center, we're going to count little c to the left and little c to the right. This time, little c is found by using the Pythagorean theorem, a squared plus b squared. So a squared is under the first fraction, so a squared is 25, and b squared is under the second fraction, so b squared is 16. So c squared is equal to 41, and c is equal to the square root of 41, which is approximately, I'm just gonna, well, I could do it, 41 square root, it's 6.4. So approximately 6.4 to the left and to the right. I'm going to count 6.4 to the left, and I have a focus from the center, 6.4 to the right, and we have our other focus. And the coordinate of the foci, take the center, take your center. Since we moved left, right, which is on our x-axis, moving to the left and to the right is associated with the x-axis. We moved the square root of 41 to the left and the square root of 41 to the right. Take your center's x value, add and subtract the square root of 41 from the center's x value and keep your center's y value, and those are the two foci. One other thing, this is a horizontal. We would say this is a horizontal ellipse because it opens left-right. It would be a vertical if it opened up-down. And I think that's it for the hyperbola.